these are the cab. Let me see, which are these? These are the end sash. Okay, back up.
Yeah.
These are the end sash for the cab of Atlantic Shore 100. There are, excuse me, there are each of the smaller ones, this rectangular width on each end, and then there are two on each side of the cab for the larger ones. Bob Reich, who is a volunteer, is removing what's called anti-rattlers. Maybe you want to zoom in on that, which are springs, pieces of spring steel that keep the windows from rattling as the locomotive tracks in Sanford. Like the noise at the time, it also helps seal it a little bit from the weather. We're planning to use most of these sash again. They are most all original, though we will show you some that have been modified. Originally, when the locomotive was built in 1906, these were varnished inside and out, but that was a common practice, and they would have been, we don't know what the wood is, but we suspect it's cherry. It's hard to tell because there's been a lot of weathering. However, this was not continued through the life of the locomotive, and the reality of a varnished finish is it's very hard to maintain. And so they painted over them with a sort of a rusty barn red oxide color. And so we're going to do that. The original varnish is still there, and let's flip the sash over to the other side and show what's there. Oh, one other detail. Bob is removing a lift handle. I should sort of lift that up so it's easier to see. Lift the whole sash up. That's a piece of brass, and there's another one down at the bottom. And it had a little strip of leather in here so that you could lift up the sash up over the windowsill, and the leather was fastened in here, and we will replace that. These are original brass castings. They'll shine up quite nicely. We sometimes, even though they would have painted them over, we just can't bear ourselves to paint over them, so we do have little accents in the finish that may not have been original but look pretty nice. You can see in this sash there apparently was a nail in the frame that stuck out and gradually cut its way into the sash. Also, the joints in these are mortise and tenons, and they have come apart. So what Bob is doing is repairing all these, pulling them back together again. We'll take the glass out and take the molding off, and we'll put paint and primer inside of these rabbets, as they're called, where the glass sits, so that they're sealed, because the water will run down both the inside and the outside of the sash, and it gets into the joints and rots them, and you can see what it's done to the wood here. Water comes up through the end grain, splits the wood, and in extreme cases it rots them. All right, let's flip this over. This, the inside has very little finish on it, but the outside still has a significant amount of varnish on it, which Bob tells me, and you can see it on this one. Let's flip this over also. Bob tells me that this varnish is extremely tough, and it's a little hard to see here, but I can feel it under my hand that it's still there. It's very rough. I don't know what type of varnish it was. It was 1906 something, and it was really good in a sense, though it would turn black and tended to alligator, so it wasn't a good finish, but it certainly did stick to the wood. Now, we also have another sash. Cut for a second, I'll bring it. As we looked at pictures of the locomotive, we discovered that originally these side sash were one large piece of glass, which you can see is quite vulnerable. And so at some point they added this cross rail, and you can see it was just tacked in with nails here, and it's some kind of other kind of wood. Also, these are repaired. This may have been made at Seashore, or it may have been made at the Atlantic Shore or York Utilities, we don't know. But this sash, I think, is salvageable, but we're debating as to whether to put this piece back in or not. With the smaller piece, it is obviously less vulnerable to smashing. We'll have to look at the pictures to see when they put these in. The original photographs, you can see they aren't there, but later they were added. All right, now we have another piece of special sash here. Now this is going to require some special glass to fit around the curves. Actually, that's not true. It's warped quite badly. I don't know why this one should have warped, though as I feel this wood that it's made of, this is oak, and oak will bend like that if it's not properly evenly exposed to moisture on both sides. This may have been some kind of repair that they had to make. So this is definitely a case for total repair. I mean, whether we can use one or two of the pieces, I doubt it very much. So we'll make a new sash. The other sash is all repairable, salvageable. You can see that the big sash did survive. Notice how loose the glass is, and obviously that's all got to be taken apart and resealed. So this one's salvageable. One of them is not. I think that's all that needs to be said. Oh, I know. We were going to talk about the glass. We were going to mention the fact whether there was the original wavy glass was used in these, or whether it was modern day float glass, which is smooth. From what we can tell, this glass has been replaced over time, and I don't think there's any original wavy glass in it. In fact, we found when we took the car apart, inside of one of the walls behind the stove, they must have used the glass for kindling, because the label from the crate was down inside the wall, and it told where the glass came from and what kind it was. I don't have it handy to know what it was, but it was just ordinary stuff they got at the hardware store, I'm sure. What you see here are the motor support brackets. On the back of a traction motor is a bracket to which it's mounted on the truck. But because the axle, or the motor, sits on the axle on one end, the other end is free to go up and down, kind of pivoting like this. They call it a wheelbarrow. Imagine a wheelbarrow you're picking up like this, and it's pivoting over the wheel out front. You don't want it totally rigid, because it would be put a lot of shocks into the motor and the gearing. So they have a spring, a bar across here, and a bolt that goes down through on these motor mounts. You'll see them more on the truck when we get out there. For whatever reason, these were extremely corroded, and so we knew we had to replace all 8 of them. There are 2 per motor, 4 motors in the car. These were originally fashioned out of a piece of 1-inch by 4-inch plate, and they would have bent this in what was called a bulldozer with a steam or hydraulic press. They would push in here against a die like that and just bend this right around. Of course, it was red hot when they did it. We don't have that facility, but we do something that they didn't know how to do in those days. We're able to weld 2 pieces together. Now, what our technician, Dean Look, did was he ground, or milled rather, a 45-degree angle in here, but left a little space in here for weld. Put the welding in here. There was also a space, similar space on the back here, welded this here, and then another fellow has ground them so that they'll fit into the channel in which they're supported. So there is a set of 8 of them. This was milled off on a milling machine. This was drilled in the drill press. Okay. These are malleable cast iron brake shoe heads, which the cast iron brake shoe fits in here, pushes against the wheel of the locomotive. There's one for every wheel, so there are 8 of these, 4 on each truck. These are in remarkably good shape. They were made by the Locomotive Car Company way back when, and they fit over the end of a brake beam. Now this is a special shape of brake beam which 100 doesn't have, and I don't know whether these were replaced out of stock that York Utilities had or what. But anyway, they do work. And these were in pretty good shape, so all we had to do was sandblast them and paint them. And we're lucky because these do tend to get badly worn. So these are all ready to go. Now let's look at where the brake beam, because of whatever, it must have been salt that was kicked up by the wheels of Locomotive 100. There's a tremendous amount of corrosion that's occurred to the point where we felt we had to replace this much at the end. It's actually 2 pieces, a thinner one, 3/4, and a 1-inch piece welded next to each other. But at the end, the brake shoe casting, brake head casting, I should say, slides over that very nicely. There's one on the other end, and we'll see in a little while how the whole thing fits together on the truck. The basic deck for 100 is made of 8 parallel longitudinal sills, which are about 5 by 12 inches in cross section. The outer 2, numbers 1 and 8, are deteriorated to the point that we need to replace them. This is number 1. As you can see, it's all rotted out on the top, and then for 10 feet along the inside of it, supporting the cab, was another block of southern yellow pine, about 5 by 8 inches, and we're going to replace that. The 2 pieces were held together by carriage bolts, 5/8 by 11 inches long, with a fairly high head. This is not the common shape of carriage bolt now. We're replacing these with new carriage bolts, but we will weld up a head on here that's of that high cross section and keep the same square nuts on the inside. Okay. Right. We're looking at sill number 1 of 8 cross sills, 30 feet long, 5 by 12 inches, southern yellow pine. The really significant part of this is that this is old growth pine, which was 100 years old or more when the locomotive was built. However, this piece came from the Bates Mill bleachery in Lewiston, Maine, where it was taken down by a company called Barnstormers, and it's basically recycled wood. We could not have salvaged the original because it was just totally rotted. We possibly could have had this made out of what they call glue-lam, where they would have just glued a whole bunch of pieces together, and that would have been all right. But we had the opportunity, and we decided we would be as historically accurate as we could, and went for material which was virtually the same as what the locomotive was built at. So we have, after a long period of time which involved fitting this, cutting tenons on the end. We had to do this by hand because we don't have the facilities they would have had at Laconia Car Company to cut these tenons in here. To put this, what I call the aerodynamics of the locomotive, on the end, they would have cut it out in a big bandsaw. I had to hack that out by hand, which is a lot of fun. And notching this so it can fit over the bolster. This piece is now ready to be installed. What we're going to do is we're going to flip it twice so that it ends up right side up. Right now it's upside down, with this notch sitting in over here. This material was delivered by Barnstormers this last fall, and we figure it weighs about 1,000 pounds. It's certainly more than we can lift by hand. We had it brought into the shop, and we have a crane with a long arm on it, and it gradually worked it all the way down so it was on the floor here, very much in our way. for a period of October, November, December, and into January before we finally decided we were able to move it. And what we did to get this up here was we have a small forklift which we brought in here, and it raised it up and set it on here. It's currently upside down because we want to put the preservative on it. This color of preservative is what was used originally. We're not quite sure what the composition of it was, but basically this is oil-based stain that you put on the outside of your house, and it's very close to the original color. Using solid wood is that it does tend to shrink, and cracks will open up in it. Now the cracks are longitudinal, so they really don't affect the strength of it, but they'll affect the appearance a little bit. You can see cracks in here. This is going to be the inside. We decided it wasn't necessary to do any repairs on them. The outside, they were quite large, though we found that in 100, there's some pictures of it and or 102, which actually shows within 2 years of the car being built, crack going the entire length of the sill. So they weren't too concerned about that. If this was a car like the City of Manchester, which was built about the same time, they would have put a piece of poplar over that, which is a finished wood. It would have covered up the cracks, and you would have had a nice finish that was smooth and filled and so forth. Locomotive 100 was a utilitarian vehicle, and therefore they didn't find that necessary. So we have done some filling on the other side, but we're not going to make it perfect because it never was. Now we'll do the same thing on the other. All right. Spectacular, isn't it? Now, I'm hoping this is going to fit. All right, we're going to need a second bar in here because otherwise this is all going to be me. Actually, this. Will that go in there? I thought you just used a bolt.
We have a bolt, we have a big distance.
Oh, it may be one of those that are out there. Wait a minute. All right, are you letting this run?
I am.
Yeah, okay. Pushing up. There we go. Just like so. Now we've got to go this way with it. No. How did I do it before? Can you move it at all? That's weird. It's like this tank, that's the problem. Oh, actually, if I could. All right, now are we in all the way? We got the maximum. I don't think that weighs 1,000 pounds. All right, now.
You get to do the same
Well,
thing.
can we get something in here?
Do the same thing.
I think that will go in there.
So,
Now, we have to move it out a little bit, but not too far. This is the more nervous part.
the part where you don't stand over here.
Now, I wonder if we want to do that with a more controlled method.
All right, in place.
Look at how level it is. One way would be to use a, well, that was one thing I was thinking about. Well, maybe that'll work. Jack. Now, what we don't know, I'm going to have to get off of that block out there.
3 inches.
Well, it's going to come close to the edge. You can't go by the hole because there's no holes in here. How long do you think you had, Phil? What we're doing is creating a 13 1/4 inch space between this sill and this sill. We have nothing to really reference it by, so we're... All right, tell me when I go over the edge.
Correct. Like you were at,
Okay, now how's it look on the end there?
it's good so far.
I mean, we're not going over the edge, right?
Yeah.
It'll come out just about even.
13 inches.
Okay. Well, checking on the bottom too, because that's the more critical. I don't know whether it's going to set exactly level.
Here?
Yeah. Yeah, 13 to 3, 8, so that's all we need. The bottom's what counts, not the top. Okay, we'll do the other end and then that will be all that we need. Sill number 1 is now practically in place. It may need a little bit of adjustment. But what we're looking at here is the outside. There were significant cracks in this, and I thought it was important to fill them. So what we did, while it was lying on its side down on the floor, is we put a number of fillings with West System and the what they call a low-density fairing filler, something that was basically wood dust, and the epoxy. Here's some that hasn't been sanded. And what we did here was fill it up and level it off, and so it's now quite smooth on the outside. Down here we have the tenon, actually the support. These 2 tenons are now ready to go. They will engage the 8x8 sill, which sits on here, that goes all the way across the end and engages the tenons. Now, still to be done on this are evening up so that the deck will sit on top of this and everything will be even. As I'm sighting across here, it looks pretty good, but there are places we're going to have to make some adjustments up or down. And then when we get to the other side, we'll have another sill that is much higher than the one that's there. This was reviewed earlier, but just for those of you who didn't tune into that episode, we had found that the tops of these sills were badly rotten or chewed out. So you can see we've replaced the top 3 inches of all of numbers 2, 3, 4, 5, 6. Number 7 looks to be all right. It's not perfect, but it's solid enough, so we thought we would leave one original one, and on the other end we did the same thing. However, especially number 2, we found that the area around these bolts was badly rotted. When the car was built, these plates were not there. We knew they were added because they were cut with a torch, which is something Locomotive Carpet Company never would have done. They're very roughly cut. And so we knew that they had added these as reinforcements, because what happened, the truck is under here, and as the truck moved back and forth when the car was operating, it moved these bolts back and forth. They enlarged the holes up on top. Rock got in there, and so these plates were put in to reinforce it. What we did was we chewed out on both ends the center of the sills and put new wood in there. Some new on the bottom. We had the bottoms were all different. We had to line up with this piece that I have my hand on here, this 2x8 that goes all the way across on top of the steel bolster. That had to be even, and so we had to chew out different amounts, which was kind of fun looking upside down over your head doing what I call dental work. But anyway, we put new to us using recycled southern yellow pine, which by the way came from a different source than this. These came from a bleachery wallpaper manufacturing plant off the airport road in Fitchburg, Massachusetts, another mill that Barnstorm just tore down. Pretty good stuff. There are some cracks in it, but generally the wood was quite solid and very nice stuff to work with, that nice dense grain. Very, very hard to chisel, by the way. So anyway, everything is now notched out and so forth. One of the difficulties was to get the bolts to come up through, that is to drill all the way up through and have the holes come out exactly the same on the bottom and the top. And we had some difficulties doing that, but as you can see there, everything was bolted together and finally worked out. The tenons, on the other end, Tom Dow made all new tenons. What I did was incorporated the old and the new, so we got close to the original locations. The tenons are at different levels only because of where these pieces came out. We will fit the mortises, which are the female parts of the sill that goes across the end, will be fitted exactly at different levels so that everything will just slide on here. Using some of the original, we'll have to reinforce them a bit, we'll have to put some epoxy in here. But we tried to keep as much of the original as we could. Here is a plate. The coupler is right here. There are two long reinforcing rods that go through here and hold the coupler on. And then there are bolts going down through this big plate here and the bracket and all that. That'll be in your next episode when we get to that. Notice how dense this grain is. I haven't counted it, but I would say that there's at least 40 per inch. That really makes this wood hard. They call it hard pine in addition to being southern yellow pine. And it really is hard. When you're chiseling it, you think you're chiseling a piece of maple here. When we sawed these off, it was really hard work. Now you can see here's this was a filler that goes way down inside here. This is much more open. Down here, much more open. It depended on the climate, that the amount of rainfall that there was and how much other wood there was around them at the same time. One of the problems that we found in southern yellow pine is what I call shelling. I'm not sure what the real term is, maybe that's correct. The grain does tend to separate for whatever reason when stresses occurred in the wood. So you can see a little bit of a filler here, and where that came through on the side, we put epoxy in here to kind of glue them back together to make units out of them. It may or may not have been necessary because the stuff is still plenty strong. In fact, this piece, the old part that's remaining on sill number 2, excuse me, we literally cut out a cross section about this much, so we left only this much on either side of the center core, which we had routed out, drilled out, chiseled out, and yet this piece was almost as solid feeling as it was when it was built, because the southern pine is so hard. If you went to a lumber yard today and got southern pine, it would be very wide grain, and the grain's all uniform because of the fact that the trees are all separated from each other, so you get maximum growth, maximum fiber production, but I would say minimum of strength. And this is another reason why it's good to go back to the old original. It's just as strong. Now, having said that, we probably never will want to haul freight cars around the way this was done originally, because it's pretty tough on the wood anyway. And so we're just doing it because of the fact we want it to be as close to the original construction as we can. One of the next projects will be to remove this sill, which was put in by Seashore in 1965. It's, as you can see, it's much wider than the others, and it's also a spruce rather than the southern yellow pine. So unfortunately we're going to have to remove it. So within the next few days, this is going to come off and will be down here. And this is the next piece right here, which we will mill till cut to length and cut the tendons on by hand right in this spot, which is going to be very interesting. Then we have to think about the order that we're going to do things in. You have to put the most rigid and immovable stuff back first. Well, that will be the truss rods, one of which is over there, two of which will be inside here, and another one over here. Those will have to go in first and be fastened in place. We'll put the ends on, but the truss rods will come through them. Then the next most or least flexible thing will be the air pipes, of which you can see some right here. This is the lead from the air compressor itself, which is sitting up there, goes down into the air tanks underneath. Though there's quite a bit of plumbing under the inside of the car, all that has to be put in. Then the next thing is the electric wiring. And you can see the motor wires over there. Those are somewhat more flexible, as you can see. In fact, they are very flexible. I think originally they were either in fire hose or, as we're going to do, wrapped in friction tape into bundles. There's an interesting thing on the side of sill number 6. If there was a fire right there, that whole surface of the sill is charred. And so those wires there show splices in them where they apparently had to do some repair work. Something had shorted out and caused a fire. Fortunately, the locomotive didn't burn up, but we'll have to do some chipping off of that and coating it with the stain. What I have my hand on is the body bolster number 2. There's one for each truck. They are the same. They were manufactured by us at the same time. The originals were very badly rusted, and we ended up having to replace the bottom cord and the top part and all the bolts. This center casting required some welding, but otherwise it was okay. And it was very important to get this in place before we did much else, because that's what holds the car and all the sills in alignment. Interestingly enough, for whatever reason, York Utilities shimmed them down. There was a piece of steel, there are pieces of steel in here, and pieces of steel on each of the side bearings, which shimmed it down a ½ inch, which must have meant that the springs of the car were getting too low and the coupler probably wasn't lining up properly. So they stuck them in there. Now it has the effect of, if you look closely right here, you can see that the end of this casting is meant to go around this and hold this in place. Well, it doesn't do that now because of the shim that we put back, because that was there, and you're just depending on the friction of the bolts to do it. Now, having said that, we hope not to haul any trains around here very much anyway, so hopefully it'll work, and it did for the Atlantic shoreline. And everything is really tight, and it may have to be tightened up again after we do some little bit of moving the car. So this is now done. This whole end is framed solidly. This is a side bearing casting. There will be a similar one facing up on the truck, so when the car moves around the corner, they slide against each other. There's supposed to be a slight bit of space in here, but that's where it will be lubricated with grease so that it allows the car to turn fairly smoothly. The car is sitting on what we call car body hoists, car body horses, some of which we made here and some of which we got from the MBTA years ago. The car is very solidly mounted. We will change their position fairly soon once we've got the wiring in place, because we're going to need, once we've got the work done out here, because we're going to need to get at things on the inside, which means we'll probably block it under these, because that would be nice and level. One of the things we do with the car is we put a level on everything, so we build it like a house, so that once we get it level, we can measurements will be easy to take. These jacks out here are just temporary, and they will come out once we get the sills on the end. This is the number 2 truck. Number 1 truck is largely together. We've replaced all of these areas here. But what's significant about this is the motor mount, which there's a bar that goes across the back, and this is turned 90 degrees, but the bar goes across to another one on the other side, so that when the motor starts up, there's some cushioning action on it. The axle will be in here, the wheels here, so the motor's supported here and is supported by springs on this side. We're replacing all 8 of these, which are badly rusted away. Moisture and salt somehow got kicked up by the wheels and pocketed right in here and just rusted everything away. So these have been made and will be replaced in here when we get to that. The other area that's in the same place is the brake beam, which goes across, kind of a U-shaped thing. And the head we showed earlier goes here. Here's the brake shoe. And the ends of those had to be replaced. This whole structure had to get rebuilt. They are all made for all of them. These brake beams will be taken out and rebuilt as necessary after we get the other truck together. This is our pattern, and we're not going to do anything with this until we're absolutely certain that the other truck is back together and we've gained all the knowledge we can from this. And it's very cold. These are what I call intermediate cross sills. There are 2 of them going across on either end of the cab underneath the big sills. And these are the notches into which the sills fit, 8 of them. They were cut originally in Laconia Car Company by what they call a gaining machine, which was just a big knife that came around on a wheel, and they would just shove this thing underneath there and they'd be made in no problem at all. Well, obviously that's a machine that we don't have anymore, so we have to do it by hand, and we'll show you that in a minute. One of the reasons we replaced this sill is the end. This is right at the outside of the car, and the water got in here and weakened it badly. The other end is not quite so bad, but it's almost the same. Is the replacement made out of, again, some really excellent southern yellow pine. And you can see we have milled out some of these, and we're going to do one more just for the show you. There's actually one more to do. We have to do some adaptive technology. In order to cut this last rabbet out, square, which will guide the circular saw, so I can cut across to the edge of this notch right here. And it's a jig that I used all the way across. So now, that one requires a jig because we want to get it absolutely square. Now the remainder, we're just going to go back and forth.
So let's,
I feel like Norm Abrams. I'm going to just put a slight mark here so that these cut out evenly. But we've got the depth with all of the saw cuts there. Now, just a case of back and forth, over and over. Etc. All right, to finish this off, what we will do is fine chisel and sand this down so it's relatively smooth on the bottom side, and then the whole thing will get painted with a couple of coats of the stain. And when we put it together, finally after fitting, we will put some caulking in here. Oh yes, there's also bolt holes that will come down through the big sills, and there'll be a couple on each one of these, so there will be 16 bolts that go down through this hole. this whole thing. One notch that's got to be cut out in the bottom for an air pipe that goes through. I have to locate that yet.